Good afternoon, sir. My name is Chanta Tiradu. Today I'm going to present my project, and the topic is error correcting codes. Today's projects contain three main points, which are the first one is introductions to error correcting codes. The second one is types of error correcting codes, and the third one is how error correcting codes works. Now let's begin with the introductions. Error correcting codes are techniques used in digital communication and data storage to ensure the reliability and accuracy of transmit or store informations, even in the presence of errors or noises. These codes add a control amount of redundancies to the original data, which allows the receiver or storage system to detect and potentially correct errors that might happen during transmission or storage. And moreover, error correcting codes play a crucial role for the following reasons. The first one, improve the, the reliability by mitigating errors. Error correcting codes enhance the overall reliability and integrity of digital communications and their storage systems. This is especially important in critical applications where accuracy is paramount, such as medical data, financial transactions, and aerospace communications. And the second one is error detections and corrections. Error correcting code can identify and fix errors that happen during transmissions or storage. This ensures that the received data match the original, reducing the likelihood of the incorrect information being processed or stored. And the third one, enhance the efficiencies. Instead of requiring transmissions of entire data blocks in case of errors, error correcting codes allow for localized corrections. This leads to efficient utilizations of communication bandwidth and storage space. And the last one is extend storage lifespans. In data storage systems, error correcting code prolong the lifespan of storage media by compensating for potential degradations or bit flips over time. And error correcting code divided into five types. The first one is Hamming codes. The second one is Reed Solomon codes. The third one is turbo codes. The fourth one is low density uh, parity check codes or LDPCs. And the last one is convolutional codes. Hamming codes. Hamming codes are simple and widely used for single bit error detections and corrections. They are particularly effective for correcting errors caused by transmissions over noisy channels. And the advantage of this type of code is that Hamming codes can correct a single bit error and detect more extensive error. They are relatively easy to implement and require minimal computational resources. And the second type of error correcting code is Reed-Solomon code. Reed-Solomon codes are powerful and versatile, capable of correcting code multiple errors and bursts of errors. They are used in various applications, including CDs, DVDs, QR code, and there are transmissions over noisy channel. And the advantage of this code is to provide a high level of error corrections, making them suitable for situations where more robust errors recovery is needed. They can handle a wide range of error patterns and are effective against burst error. And the third type of error correcting codes is turbo codes. Turbo codes are modern error correcting codes that use multiple layers of encoding and interleaving to achieve excellent error correcting code performance. They are widely used in wireless communication standards. And the advantage of this type of code is that to provide nearly optimal error correcting uh, capabilities approaching the Shannon limit for channel capacity, and they are well suited for challenging communication environments with high level of noise and uh, interference. And the fourth type of error correcting code is low density uh, parity check codes, or in short, LDPCs. This type of code are known for their excellent error correction performance and efficiencies. They are widely used in modern communication standards, including Wi-Fi and digital broadcasting. And the advantage of this type of code is to offer a good balance between error corrections, capability, and computational complexities. They all approach the Shannon limit and provide reliable communication over noise channel. And the last type of error correcting codes is uh, convolutional codes. Convolutional codes use shift registers to encode errors, making them suitable for continuous data streams and real-time communications. And the advantage of this code are well known suit for scenarios where error tends to occur in clusters or patterns. They are used in applications such as serialized communication, wireless network, and dispatch communications. Now, let's move on how error correcting code works. Error correcting code works by introducing control redundancies into the original data before the transmissions or storage. These redundancies allows the receiver or storage system to detect and potentially correct errors that occur during the communications or storage process. And here's how detections and corrections using this code generally work. First, it's adding redundancies before uh, transmitting or storing the data. Error correcting codes add extra bytes to the original data to adding a large block of data, and these extra bytes are carefully calculated based on the properties of the chosen error correcting codes. And then the adding bytes are often referred to as parity bytes or check bits. These bits carry redundant information that helps the receiver or storage system identify and correct errors. And then it encoding. The process of adding redundancy is known as encoding. The original data is fed into an encoding algorithm along with the calculate parity bits. And the encoding algorithm process the data and generates the encode data, which include the original bits along with the added redundancies. And after that, transmissions or storage to the encode data, including the original data and added redundancy, is transmitted over a communications channel or stored in a storage medium. And after that, error detections. Um, When the receiver receives the encoder, it applies a decoding algorithm to analyze the received bits. And then the decoding algorithm checks the parity bits and compares them with the corresponding bits in the received errors. If the parity bit does not match the expected value, it indicates the presence of errors. And after that, error corrections. Depending on the type of error correcting codes used, the decoding algorithm can identify the locations and patterns of errors within the received errors. For certain types of error correcting codes, such as read Solomon codes or LDPC's codes, the receiver can use mathematical techniques to correct the errors. It calculates the most likely correct value for the erroneous bits based on the uh, redundancies informations. And the last step is output and data recovery. After error detections and correct correction, the receiver obtains the correction data. In this case, where corrections is not possible, the receiver may request transmissions of data. And after that, in storage systems, the correcting data is retrieved and used for the for the further processing. And um and overall overall error correcting codes are essential tools for ensuring the accuracy and reliability of digital information transmission and storage, and enabling seamless communication and safeguarding data integrity in a wide range of applications. Now my presentation has become to the end. Thank you, sir, for your precious time and attention, uh, listening to my presentation. Thank you.